I'm going to do a video key for quiz, what is this, 6, quiz 6, so that you can kind of go through and compare your answers. So the first question is, you'll use the following reaction for all the questions on this quiz. Label which part of the reaction each box contains. You should have each of the following labels: nucleophile, substrate, electrophile, substituted product, solvent, and leaving group after departure. So when I'm looking at this, I guess the first thing I note is that we have a something with a good leaving group. Br is a good leaving group. We have a nucleophile. It's negative. And it looks like we get a substitution. So where the bromine used to be, this thing has replaced it. So I'm immediately thinking this is a substitution reaction. And so this is my substrate or electrophile, the thing that gets substituted on. This is my nucleophile, box 2. It's the negative thing that's going to be attacking, and then that bond will be breaking. This third box, CH3OH, this is the solvent. Box 4 is the substituted product. And box 5 is the leaving group after departure. Okay. I got distracted. Okay, so that's 5 points. The next question is indicate if the reaction above is SN1 or SN2 and tell how you know. So this is something that I've given similar questions like this to my in-person classes. And a lot of times they'll say it's SN1 or SN2 because it happens in 2 steps. But we're not given the mechanism here. We're just given the starting material and the products. So you can't really know if it's happening in how many steps or not. It's just telling you that a substitution is happening. So you have to be able to figure out how many steps it's happening in based on the electrophile and the substrate. Another thing that I see a lot in this is students talk about the solvent, but the solvent is not the thing that determines which reaction will happen. It helps favor one reaction over another, but it doesn't determine which reaction will happen. So in this reaction, I think it's SN2 because we have a strong nucleophile. And that will get you, saying that it's SN2 will get you 1 point. Saying that there's a strong nucleophile, which favors SN2, will also get you 1 point. Yeah, 1 point. But the third thing that I see students do a lot is not notice the electrophile. So it wouldn't matter if we had a strong nucleophile if this was a tertiary leaving group, because they can't do SN2. But this is a secondary leaving group, so that will allow SN2 to happen. If it was a tertiary, that wouldn't work. So you would get a point for that as well. So you get a point for indicating that strong nucleophiles favor SN2. They need a secondary leaving group, and so that's how we determine that it's SN2. Okay, and then the last question, if you wanted to change the reaction to the other substituted mechanism, what would you change? So I would change the nucleophile to, instead of this isopropoxide, I would change it to isopropanol. But also, if you just said to a weak nucleophile, I will accept that. I would accept either of those. So a weak nucleophile rather than strong. Fine. A neutral nucleophile would also be fine. I think that is worth 1 point. Yeah. And the last question, is the solvent used in the reaction for question 1 a good solvent for the reaction, and how do you know? So no, this is not a good solvent because protic solvents tend to solvate negative atoms, therefore slowing down the reaction. Now, if you said no, protic solvents aren't good for SN2, I'll give you 1 point for that. But I really am also looking for, with that how do you know piece, like why are they not very good at that? And it's because they solvate negative atoms. So aprotic solvents favor SN2 because they tend to solvate positive things. Positive atoms. So then they leave the nucleophile unimpeded. So I did want you to go one step further from that. Okay, that is the answer key for quiz 6, and let me know if you have any questions on that.